Just waiting for a call from your side. Okay.
Okay.
Yeah. So we'll start here. Good
Okay.
afternoon, all. I'll share my screen first so that you can start. Yeah, my screen is visible now.
Yes, sir.
Yeah. Okay. Good afternoon, all. So we'll start with today's topic of integration of green energy with electrical vehicle charging station. Okay. So yesterday we just gone through the BMS what we are using in the battery pack. Now the next topic is the EV and charger we are skipping. We are directly going to the integration of green energy with the charging station. So before we go to this renewable energy, I think we should just touch what exactly is the EV, that is electrical vehicle, and the charging station. So just a brief introduction about these two, and then our whole system will get covered, and then we'll shift to this integration of green energy with this all equipments, right? So we'll start with the electrical vehicle. So I hope everybody now aware what is the EV electrical now. So it is nothing but the electrical vehicle. The short form is EV, and it is a type of vehicle that is powered entirely or partially by electricity instead of traditional internal combustion engine, which is used generally for the petrol and what you call LNG or CNG or diesel engines. So apart from that, it is partially or fully driven by electricity. Electricity in the sense here it is a battery. So battery power, and in some cases it is hybrid also, where in I mean combination with IC engine, this electricity is used. So that is we are saying it as hybrid EV. So we'll just go through the types of EV here. So these are some typical vehicles. First is the battery electrical vehicle, which generally we are using in India most oftenly. So this is fully electrically powered with the rechargeable battery. It doesn't have any IC engine or CNG or any other engine inside. It is electrical motor inside. That is AC motor generally we are using for four-wheeler and truck, bus. And for two-wheeler, it depends on the OEM. Either it is DC motor or AC motor. Generally, they means this EV doesn't emit any pollution. So there is zero tailpipe emissions with EV. The examples what shown here are the US based or Chinese companies, because the presentation when I made that time it was not prominent in India, but now Tata vehicles are there. The most famous is Punch, Tigo, Tiago. Lot of vehicles are there now in India as well, which are you can say are the EV vehicle. Another is a plug-in hybrid electric vehicle. So these actually we are not using in India. They are I mean initially when started this EV, that time it was in connection with or in combination of IC engine. They have just added one more engine, that is electrical engine, AC motor, and it was driven with the help of battery. So it is just like your CNG vehicle right now, CNG plus petrol or CNG plus diesel. I don't think diesel is there, but CNG and petrol combination, it is same way, battery and petrol. So whenever battery is there, it will work on battery. When battery is fully discharged, you can shift it to petrol. But this combination was the vehicle cost was not that affordable, and that time it was running on the lead acid batteries, maintenance free batteries. So the battery weight and the power required was huge, and that's the reason these vehicles were just made for smaller size. You can say three-wheeler or four-wheeler, but not in India. Right? The third variant is the hybrid electric vehicle, which I think Maruti Suzuki has come up with this option. So initially they are not jumping directly to the EV vehicle, so they are starting with hybrid vehicle. So here basically the vehicle will run on the you can say on the petrol, that is IC engine they are using, and the in addition to that, this batteries are there, which are getting self-charged with the motor running or vehicle running, this and the braking whatever we are applying. So on that basis, these batteries are getting charged. So you don't have to separately charge these batteries, and these batteries are giving power to the vehicle in case of idle condition, whenever you want to stop at your signal, or in city whenever now the battery fully charged. So the vehicle can run on the battery also. So that's the reason these vehicles are giving more mileage compared to IC vehicle. So generally our vehicles are giving, let's say 13, 14 kilometer per liter, but these vehicles are giving more than double of what we are getting in IC engines. The fourth option is fuel cell electric vehicle. So these are yet to come in India. Means fully operational, but already R&D has been done. Vehicles already made, and they are running on the road for trial purpose. But since the availability of hydrogen is the issue, these are not yet commercialized. But Reliance has already manufactured with the help of Ashok Leyland some of their trucks using hydrogen cell, and they are using it internally for their internal use. And whatever hydrogen they are producing, they are using it for their trucks. So these are the mainly four vehicles where you can say they are related to electrical segment, but the prominently we are using the first variant, that is the battery electric vehicle, and the third vehicle, which is hybrid electric vehicle. So hybrid is also getting more popular because of their mileage. And now the upcoming technology is the full fuel cell electric vehicle. So once we get starting getting this hydrogen fuel cell, I think this vehicle will get more popularity in India as well. So Tesla has already developed this. Toyota Mirai is there, Hyundai is there. So these vehicles are already running in Korea and US. So here we will discuss only about the first variant, that is electrical variant, electrical vehicle. So electrical vehicle is having the major the components are the battery, of course, the battery pack. Then it is a DC to AC converter. because this battery is DC power and motor is AC generally. So we need to convert this DC into AC with the help of converter, and then motor will drive the vehicle. So these three are the major component inside the EV. Then another power electronic component is DC to DC converter, where this DC supply, because this battery pack voltage is very high in the range of 300, 200 to 300 volt. And the accessories what generally are used in EV is around 12 volt or 24 volt. So we have to reduce this voltage to 12 volt or 24 volt, so that other accessories we can use it with the help of DC-DC converter. So that this section is used for giving the supply to our other application in the vehicle. Now another major block in the EV is AC to DC converter. So this is nothing but the onboard charger, you can say, where AC supply is connected from grid, and this AC is converted into DC to charge the battery. So this is onboard charger. So one more line is there, which is coming from this point, battery point, and coming at this output directly. So here we are connecting the charger directly. So high power charger, or you can say fast charging power, is connected directly to the battery, and it will get charged at faster rate. So this line is not shown here, but that is also available. This block just shown for the understanding purpose. This is a gasoline engine. In case of hybrid, this engine is also there, and this is driving this motor. Right? So these key components already we have seen in the block diagram here. So the explanation is given here for all the major blocks. One is battery pack. Of course, you know about the lithium-ion battery. So these battery packs, nothing but the series and parallel combination of lithium-ion cells to get the required voltage and required capacity, and which is storing the electrical, of course, the electrical power required for the motor. Now, another major component is the electrical motor, which is converting this electrical energy into mechanical energy to drive the wheels. And the type of includes the AC induction motor, permanent magnet synchronous motor, and others are also using. In addition to this, what I said, the DC motor is also getting popular now in two-wheelers. So they are coming up with a DC motor also, so that you can reduce one this AC, this block, where you are converting this again DC to AC. Another is the power electronics, where we are saying whatever conversion is there, DC to AC, AC to DC, auxiliary power we are generating. So all these coming under the power electronics section. This is onboard charger. So onboard charger is nothing but the rectifier or charger, you can say, which is converting this AC into the DC, which is charging ultimately the battery pack. And AC can be from your grid or from your utility or from your residential or the commercial outlet. So that AC supply directly given to the vehicle. Then the regenerative braking system. Now, this is not applicable here in the pure EV, but now some companies or some OEMs are coming up with this advantage also, like whatever they are using in the hybrid, the same system they are applying in the EV vehicle also. So whatever energy we are losing during the power braking or the accelerated mode, that energy is again converted back to the DC, and that is again used to charge the batteries. And of course, another major important function or component is the thermal management, where we already saw that into our BMS yesterday. So it is generally protecting the battery. And apart from that battery BMS, VCU is controlling the temperature of other major component as well. Like charger, you have the DC-DC converter is also there, DC to AC converter is also there. So the power component of these blocks, there also you have to manage the temperature. So anywhere in the vehicle, wherever temperature is exceeding, this thermal management system is there to take care, either to cool it down or switch off the vehicle in case of excess temperature to protect the vehicle from any damages. Right? So these are some advantages of the vehicle. We all know about the zero emission is there, less air, noise pollution is not there. Then the lower operating cost. If you compare the means mileage with respect to petrol cost, this is 1/10 of the cost. At 1/10 of the cost, you can run the electrical vehicle. And the since it is electrical motor driven, so less mechanical parts are there inside the vehicle, which is lowering down your maintenance cost again. The energy efficiency is more because directly this DC energy is given to the motor, and there is no other component where inertia or other things are there which is consuming more power, or more power is required to drive the motor. So that part is again reduced here. So we are getting more efficiently the utilization of the DC power. Another advantage in India, especially, is the government incentives. So whatever incentives government are giving in terms of let's say subsidies, rebate, or some tax credits to the OEMs. So that is again reducing the price of EV in India. So these are some advantages of EV. Now we will shift to the charging of EV. So we completed the battery pack yesterday, battery pack along with the BMS. We now understood what is the EV, what are the major components inside the EV. Now this charging EV, charging of EV, it is either it is outside the vehicle, or one small charger is given inside the vehicle, that we are calling it as a onboard charging. So it is low power actually charger, which is taking the power from your house where 15 ampere supply is available. So that 15 ampere supply, small charger of let's say of around 10 to 15 kilowatt. So that power is generally taking 10 to at the charging rate is very less, around 10% of per hour charging. So it will take almost 10 hours to charge the battery. So these are that is onboard charger. So another fast charger is also there, where direct DC supply is given to the battery bank, and that batteries are getting charged at higher rate. Now the EV charging, the basics are like the batteries require DC supply. So you need first DC supply to charge the battery. That and the most common whatever source is available with us is AC supply. So that AC supply we are converting into the DC and charging the batteries with the help of fast charger, or giving directly that AC to the onboard charger, which is charging the batteries. So now depending on the charging methods of AC may be converted to DC either by the vehicle onboard charger or directly by the charging station. So we'll just go through what are the different type of chargers available, uh, or you can say the level of chargers available. So first, of course, is the onboard charger, which require a very low means power, because it is charging the battery at very slow rate, almost at the 10% of capacity of the battery. So the household supply or household this outlet is available, which is 15 ampere rating, which is sufficient for charging the vehicle. So it is charging our vehicle at the rate of let's say 10% of charging per hour. So with this rate, your vehicle will need at least 10 hours to get it fully charged from 0 to 100%. Generally, we are not charging the vehicle from zero. Some power is already there at the rate, means SOC is never going at zero. So 10% or 20% is already there, and we are not charging at the same time to the full level. So around 90% charging is also sufficient. So almost you can say the charging range is from 10 to 90% of the battery capacity. So that is the ideal charging rate, where your batteries are getting more power, and they are getting charged at very fast rate during this range. So from 0 to 10, it is taking more time, and at the same time from 90 to 100%, it is taking more time. So that's the reason we are avoiding that portion of charging the batteries, because 10 to 90% charging of your battery is enough to give me the required capacity or required mileage in this case. So, and these level 1 charging are, suitable for overnight charging at home. So, if you are using your vehicle only for the, you can say the office commutation or for day use, and then it is idle at the night. So, during that time, you can charge your vehicle at your home. When you are sleeping, your car or your vehicle is getting charged for next day drive. So that is the purpose of having this slow charging facility. Second level charging is it is again slow charge only, but you can say it is a little bit having more power than what we are having at the slow charging. So even though our outlet is of 15 ampere, we are not using that at the full rate in house. Maybe around 5 ampere or 6 ampere, or you can say 10 ampere maximum. So up to maximum 10 ampere only we are using it. But when it is having the industrial outlet, we can charge that at a full, you can say 15 ampere capacity. And either it can be a single phase source or a 3-phase source. So depending on the where you are using it. At workplace, generally 3-phase supplies are available. So if I consider the 3-phase supply at 15 ampere, let's say, so almost 10 kilowatt power is available. So 10 kilowatt power, and let's say your battery is having of 60 or 70 kilowatt hour. So there also you need at least 5 to 6 hours to charge your batteries, because the charging rate again here is from 20 to 40% of the speed per hour. Okay. And these are common, the places are like your in big societies, you have the parking place where industrial supplies are available, 3-phase or single phase 15 ampere supplies are available. So with that help, or at workplace, some companies are giving that facility to the employees to use that power at some concessional rate to charge your vehicle. So there you can do this charging as also. The third is the fast charging facility. So this generally we are having the fast charging station like the petrol pump what we are generally using for fueling our vehicles. So these are the similar line. We have the charging station as well, where it is getting charged within half an hour uh, for this 80% of capacity. Okay. I hope I'm not going at a faster rate because there is no interaction or cannot see you. Uh, I'm just speaking. If you have any doubt, you can just interrupt me in between. You can ask the queries as well, so that if you have any doubt, we can clear at the same time.
Okay, sir. Dear participants, if you have doubt, you can ask in between also.
You can ask directly also because I am not able to see the background as well because my full screen is the PPT mode. So,
Okay.
here up to this level, it was just the introductory part of your electrical vehicle and the charger. So this was not the topic we wanted to discuss here, but since I thought I should not directly jump on this charging infrastructure, we should have this basic information at least. I understand you must have gone through all these things, but it is just helping you to refresh your whatever knowledge you had. So that was related to EV and the charging facility required. So this power also, yesterday, I think we discussed how much power is required to charge the vehicle at fast charging. Now, the infrastructure, what we are going to discuss here is the charging station only. So, if we are discussing on the charging station, means we need a very high power there. So it again depends how many outlets are there at the power station or the charging station. How many charging stations are there? Let's say three, four, five. How many are there? If you go to this petrol pump, you can see many outlets for petrol pump depending on the petrol pump size. So on the similar line, in India also, we'll be having these kind of charging stations now. They are getting built up. There are some few companies which are taken some initiatives to build their own charging station as well. OEMs are also putting their interest in building this charging stations. At every petrol pump, they are giving some charger, single charger, wherever power is available, because the most requirement is here the high power. Because if you want to charge the battery at very high rate, you need more power. So in India, generally, all these four vehicles, a four-wheeler, are coming with the battery range of 30 to 70 kilowatt hour battery range. So if I want to charge the battery at, let's say, 2C rate, so if I want to charge at 30 minutes, if I'm keeping the target, so I should charge at a 2C rate. So 30 kilowatt of battery means I need 60 kilowatt power, and for 70 I need around 150 or 140 kilowatt of power. So that is the basic requirement which need to be catered if you want to establish uh, a charging station at any place. So that is I'm talking about a single outlet. If you want to build a charging station with, let's say, 10 or more outlet, multiple times you need that much power, and the facility from where you are getting this power of that capacity, maybe in big infrastructure is required basically for charging, to build the charging station, or to have the fast charging multiple outlets. So this only we will discuss first, and then we will shift it to integration with renewable energy here. So the this before that we'll just have some refresh our this on the charging process. So here these are some connectors. Means what is the requirement for the charging? Now the connection. So connection type 1, type 2 connectors are basically for the AC supply, and CCS and CHAdeMO is generally connectors we are using for the fast charging purpose. So it is DC, directly DC connectors are there. So that is charging the batteries. So these are the connection point of view requirement. Then we need a communication with respect to BMS and charger should communicate each other, because this is charging the battery at a very fast rate. So charger should know at what rate it should charge the battery, because charger is universal, but vehicles are not the standard here in India. We have all kind of vehicle, right from Comet, which is having very low capacity battery, to the Vitara, or maybe Tesla is coming in India now. So their capacity requirement is very high. It is in the range of 100 kilowatt hour. And for Comet, I think it is 15 or 20 kilowatt hour. I don't know exactly the capacity, but it is in the range of 20 kilowatt hour. So 20 to 100 kilowatt of power is required. And that again, the voltage, or you can say the current is also different. Voltage is also different. So charger is universal here. So charger should know at what voltage, at what current it should charge the battery. So that's the reason communication is very important with the battery. So it is kind of handshaking is done, and then charger is ready to charge the battery. So charging initiation is the same what I told. Fourth is the charging control. So charging process is managed by the battery management system to prevent from overcharging and overheating. That already we discussed this yesterday. And charging rate, again, it is decided by the BMS, because whatever batteries we are using inside, that is limited with the charging current also, because we cannot charge that battery at very high rate. Let's say my batteries are having the capacity of 1C or 2C. I cannot charge more than that rate. So that again is decided by the BMS. So all parameters are controlled by BMS. And then the feedback to stop the battery from fully charged. Once it is charged, we have to disconnect from the vehicle. So this is the general procedure, or the steps we have to follow during the charging of any vehicle. So you might have seen some this kind of charger at charging station. So these are the charging station, typical charging station, where AC power is also there and DC power is also there. So this side, I think it is AC power. So it will take more time to charge the battery compared to the DC power, which is charging at very high rate. So these are directly connected to the battery, and this is connected to the outlet. So if you see this outlet here, they have both the terminals, AC as well as DC. So the connector, this BMS will detect what kind of source is connected here, either it is AC or DC. And then accordingly, it will give command to the charger to supply the voltage or current to charge the battery. So if it is AC, then onboard charger, that AC supply will be given to the onboard charger, and then it is getting charged. If it is DC, then again it will communicate with the charger, and they will decide at what current voltage it should charge the vehicle. Now the chargers are coming with prepaid, postpaid, both facilities in India. Whatever charger I made, two, three manufacturers here, they already are in, I mean, development stage of making the charger with, you can say, the prepaid kind of thing. Just you have to go there. Uh, I mean, charge your whatever that card with the amount or the kilowatt capacity, and then it will deduct some money from you, and then it will start charging your vehicle. So that is a prepaid kind of thing. So this is again, means human intervention is not required there. So you have to just go there, park your vehicle, do the connection. Then they will ask some, I mean, so you'll have to connect with the app of the charger on the mobile, and then you can start charging that vehicle with that app. So again, you can say it is kind of the payment we are giving it to the charging station owner. But this is human intervention is not there. You have to do yourself. So these kind of chargers are also coming now into the services. So this is the infrastructure generally required for charging the vehicle. So this is grid where AC supply is available. So I am considering this is three-phase supply, normal 415 volt. If it is not 415 volt, let's say it is 11 kV or 33 kV, then step down transformer will come there, and that will again reduce it to, or step down that voltage to 415 volt, and then it is given to the charger. So this four blocks represent charger, so fast charger you can say. So it is having inbuilt filter circuit, AC to DC converter, and then DC to DC converter. So this block is very important because it will decide which vehicle is connected here, and accordingly it will give that voltage to the charging circuit. So and this is control system where we are handshaking the commands from BMS, and controlling the charger here to charge the vehicle. So some flow is mentioned here, which one is unidirectional, bidirectional. So some power is again here we have shown as bidirectional, because now we have the facility in the charger itself, which is taking this power from the battery as well, and converting that DC into AC. So let's say you have the full charge vehicle at your station, and you don't have the power or utility, AC is not there. So at the same time, you can convert this DC back into AC to run your station in case of emergency. So that kind of chargers are also now people are manufacturing or developing. So you can say these are the bidirectional chargers. So this is about the infrastructure requirement. Now we will just go through the, you can say the list of what is the required in infrastructure to develop the infrastructure for a pure charging station, if you want to, let's say, make. So first is site selection, because the sites whatever available here in India are mostly the petrol pump or parking areas, but that is not the right way of having the charging station. So charging station should have the separate site where all vehicles are coming. They will park there. all the vehicles, multiple outlets will be there, high power will be available, electrical power supply, then charging equipments are available, sufficient. All charging equipments are equipped with communication, and networking is also required. Then safety. Safety is the most, I mean, important here, because a lot of batteries or a lot of vehicles are standing there. All are in charging condition, consuming more power. If I consider at an average, let's say 50 kilowatt of power for each vehicle, and let's say I want to build a power station or the charging station which can charge, let's say minimum 10 vehicle, then 500 kilowatt of power is required. So same time, if all 10 vehicles are getting charged at this 50 kilowatt, then 5 kilowatt, 500 kilowatt of power is getting consumed from the grid itself. So you can imagine how much heat is getting generated. Uh, that's the reason this safety and compliances are very important. Installation requirement. So all these, whatever I listed down, are the I mean the major requirements which is required for the charging station. So now we are moving into this direction, because at present our requirement of having the charging station is very less. But going forward, when these IC vehicles are getting absolute, or you can say minimized, and EV vehicles are getting in place of this EV IC engine, then we need more such kind of power station or charging station, and these facilities are generally required. So now, if in future, suppose if you want to replace this petrol pump with this station, the first thing is requirement is the power. And if that power station or that petrol pump is in the heart of, let's say, city, you cannot run the high power line there to charge your or to get that much power. So that's the reason single or two around mostly maximum 2 points are there using for giving the charging points. But in future, maybe a separate line will have to run to give that high power to the charging stations. So these are the typical steps, or you can say the requirement of charging infrastructure or charging station, you can say. So these I have just listed down. I'm not going in detail with this requirement, because again it is a separate topic. It is huge requirement here. Every point here, whatever is mentioned, has some important, and means we can discuss. Maybe we can have a complete subject of this topic. What kind of infrastructure we can give it to the charging station here. So maybe this can be the chapter of your curriculum. So you can, I mean, imagine how much big scope is there in this area. So this is the general what picture we see wherever the parking are available, slots are available. So they are using this renewable energy, generally the solar panels, to supply the power to this what you call the charging station. But of course, these are very slow rate chargers, not required very high power, and they are charging the vehicle at a very slow rate, because they are idle or standing in our office area where we are working. So 5 to 6 hours power is sufficient to charge your vehicle. So that's the means rating we are calculating here, and these are generally used for our personal use, not for the what you call the commercial use of it. Now, the power station or charging station, what we discussed is for the single outlet. Now, if you want to develop a multiple outlet, so you can use your solar panel. You should have your grid where high power supply is available. Then you should have the battery energy storage system, because in case of the solar is available, let's say, and there is no vehicle to charge the I mean station. So whatever power is generated by solar power, that solar panel is getting wasted. So to have that utilization of renewable energy, you should have the storage energy also. That is battery storage energy we are saying. So this power, whenever vehicles are not there and excess power is available from solar, it is getting charged, utilized to charge the storage, battery storage system. And in case of, let's say, grid is not there, then again, a similar application, this battery supply can be utilized to charge your vehicle or charge your the charging station. So this is the block diagram of, you can say, a major block where we have shown the important power components required for utilizing the renewable energy into the uh, uh, what you call the charging station. So if you don't have the renewable energy, then simply grid is connected. Whenever grid is available, you can charge your vehicle. Grid is not there, these vehicles are idle here. No power available, no charging will be done. But if you have the solar power, if you have the battery storage energy system here, that can give you the additional power, or it will reduce your demand from the grid. So whatever power is generated here can be utilized to charge your vehicles. So your dependency on grid can be reduced. So this is the advantage, or maybe the this may be the model in future. Everybody is going to adopt, because power availability of high power will be less chances. So how you are going to generate the power? So it is only with the help of renewable, maybe either solar or wind. Wind again require more space. So wherever space is available, power can come, or the high power tower can be installed, and power can be brought to that area. So wind energy, generally we are not targeting for the city, but maybe if it is outside city or on the highway, then again wind energy can be considered for generating the power. So, but mostly in cities, solar are generally used because of their low, what you call the area requirement, or you can use the rooftop of your building or your charging station, and you can utilize that floor area for generating the power. So this is the advantage of solar panel here. Okay. So you have any doubt? We can just stop for a minute. We can take some questions here. Or
Dear participants,
we'll take at the end of session.
okay.
Okay. Yeah. So this is the general block diagram of any power station or charging station, which will be coming in India. So these are again the explanation of each block, what we discussed already into the block diagram. So solar panels, generally they are converting this solar energy into electrical energy. That electrical energy is means connected to DC bus, and then it will be utilized to charge the battery. So here DC you cannot directly from panel, you cannot give it to the vehicle, because vehicle need some controlled voltage, controlled current. So these DCs are given to the charger. You can say we have already seen the block diagram of this charger here. That DC can be given maybe at this point, so that this DC-DC converter will convert to the required voltage for charging the vehicle. Then wind turbine, as I said, can also be considered to generate the power, AC power. So wind turbine generally, I mean, generating AC power. That AC power again cannot be used directly by the charger. So again, this, let's say, suppose I want to install a wind turbine here. So that wind turbine shall be integrated with the grid, not with the charger, because that is having function of AC. So directly we can have the net metering here, and that whatever power is generated by wind will be given to the charger as an input. So these wind turbines we can use. Then the battery storage, battery energy storage system. So BASE or ESS we can call it. So this is again used to store the energy whenever load is not there. So whenever vehicles are not there for charging, whatever energy is generated by this renewable, either you can feed it back to the grid. You should have the system where you are feeding back it to the grid with the help of net metering, or we can store that energy into our battery energy storage system. So having battery energy will give you the more advantages, because that energy, whatever excess energy, you are not feeding back to the grid, but utilizing for your future use. So whenever the peak demand is there from grid, the rates applicable, not in India, but outside, wherever you are taking power at the peak demand, they are charging you at very high rate. So to avoid that, generally in European countries or US, they are using this battery energy, whatever power is stored, for charging the batteries. So that whenever peak demand is there, they will utilize this power, and whenever power is available in at the cheaper rate, they can charge the batteries, keep this battery storage ready for charging at the peak demand availability. So this can be the use of this battery going forward. So at present, we are not using in India because we have the same rate for 24/7. So whatever consuming power we are consuming, we are charged at the same rate. So we don't care about using the power at maybe the peak rate, or we are not bothered to see whether it is peak demand or no demand. So we are just utilizing the power whenever is required. So that can be avoided in case of this battery energy storage. So that is the major function of this ESS in case of uh, controlled voltage, controlled power, or whenever it is required. That situation comes, then we can utilize this ESS. Then vehicle to grid also we can do it. So that's what I told earlier here in this block. So whenever grid is not there, battery is not there, you have the solar power, you have charged vehicle. But now suppose if you want to utilize your some emergency purpose, the power, you can utilize these batteries, whatever your vehicles are there. You can feed back to the charger, and charger can generate again the AC voltage, and that AC voltage either given back to the grid if it is having excess power, or can be utilized for the station. So that is the vehicle to grid requirement. And the hybrid system. So hybrid system is nothing but again the combination of all solar, wind, battery storage to get the 24/7 renewable power. So here we don't have the grid, but the complete renewable power can be generated at their own. So we are means neglecting or reducing our dependency on the grid availability. So even though grid is not available, we can design a charging station which can run at renewable energy. So here the battery storage is very important. So whatever power, let's say, depending on how many vehicles you are supposing or you are, I mean, planning to charge at that particular station, you have to decide how much power is to be stored in that battery. So you can design a system or power station where how much solar is required, how much wind will be there, how much battery storage energy will be there, the capacity of battery storage energy. And then you can deliver that power 24/7 to the required load. So again, this is a big exercise where you want to design a power station or charging station with the help of renewable energy. So I think this model is going to be very feasible. You can say the uh, what you call the return on investment ROI will be less here because you are not using the grid power, because going forward grid power rates are going to increase. At the same time, the renewable power, whatever is getting generated by these sources, is going cheaper and cheaper day by day. If you have gone through the rates of solar power generated, maybe I think 4 5 years back, if you have heard, at the rate of 4 rupees or 5 rupees, they were selling this power. Now it has come down to less than 3 rupees now. So this is the power of renewable energy here. So at one hand, our power generated by renewable is getting reduced, and on the second hand, whatever power we are purchasing from this electricity board, it is increasing day by day. So to reduce that, renewable only is the solution where we can get the cheaper power, and we can I mean get our return back whatever is invested at more faster rate. So this model, whatever hybrid model or 100% renewable model, we can say will be I mean I think it is going to be the next India, you can say. So this is what model we are expecting in future. So we can say the PV array is connected, energy storage is there. Grid, I have shown it red here because that we don't want to utilize for charging purpose. Maybe you can say it is used for emergency use only, but we want to avoid this. Our dependency should be on the renewable. Then only this model will be feasible, or you can say we are means utilizing these vehicles at 100% carbon free emission. So green energy is generated and green energy is used to run the vehicle. So this is what the 100% green energy we can say. So PV array, they are generating this DC. MPPT is used to boost this DC voltage. They are connected to common bus here, TC bus. This energy storage is the battery unit, which is having the bidirectional converter, which is again converting this DC to the required DC here. to get this constant DC voltage here in case of discharging. In case of charging, again, this DC, whatever is available from this solar, is used to charge these batteries. So these are bidirectional converters. Again, here bidirectional converters are required to charge your batteries. So that again, here what we are presuming here is to convert this DC into the required DC in this direction to charge the vehicle, and in opposite direction as well, because this whatever charging station we are building are having that facility to charge or discharge both at the same time. So why not use that facility? So this is going to be a next what you call the topology, or going to be the method of this charging stations. Then these are some requirement of the charging station, or you can say the charging. Going forward, if I want to build this complex charging station, because here I cannot just simply keep the solar energy or the battery energy system and do my simple way of charging, because I need some smart way of working in this area. So I should have the dynamic load management system where, because as I said, going forward, let's say your rates are getting changed depending on the peak requirement or the low requirement, then I should be able to use that whatever power is available from this battery, either to use the battery power or to use the solar power or use the wind power, or shall I use the grid power. So that again depends on the input what is available at that particular instance, and what load is or how many vehicles are there to uh, charge that at the station. So this dynamic load management will always be there, because the generation will be different, uh, peak demand will be different. So all these variations we have to adopt, and we need a very stable, you can say, load management we have to do. Otherwise, this complete system can get collapsed if you're not demanding. Let's say your power generated is less, you're demanding more, then that complete system will get collapsed. So the load management is very, very important. Then time of use of optimization. Then again, this is the charging rate at what we are charging, what is the renewable energy available. So the pricing incentives or scheduling, we have to do it. Then AI again can be used for integrating all this or managing all these power resources available in a better way. Because let's say solar is, you can use only for 6 to 8 hours in a day, and solar is available. The first priority should be given to you utilize that power, either to charge your vehicle or to charge the battery energy system, whatever you are having, or feedback that power to the grid. So that should be because that power generated is free for you. If you are not utilizing it 100%, then it is going to be wasted. So I mean to say, your the load management or whatever control system you are making, it should be uh, uh, that much intelligent that which one should I use it. So it should decide on its own. Either I should use the solar, or shall I use the wind? Because if you compare again wind with solar, wind is the more you can say uh, it is not giving me the stable power. So whenever wind is there, I will get that power. So I should give the priority to utilize that wind. Whenever it is generating, I should immediately use that power. Solar, at least I am aware that yes, during these 6 to 8 hours, I'll get this much power. So there I can rely on the solar system. But wind, it will keep on varying over entire 24 hours, you can say. So at night also I'm getting some winds. So there also power will be generated. So separate storage system is required for utilizing that power. So we need a control system which can decide all these things. Then grid integration is also a big challenge for us, because if we are having multiple renewable resources at our charging station, we should be able to integrate everything with the grid, because whatever demand is there at the charging station should not overload the grid. At the same time, we should means utilize whatever power is generated from these renewable resources. So the priority should be given for that renewable resources, how to utilize it internally, and then excess power can be given to the grid. So that is how this grid integration is taken into consideration. Another is the microgrid concept is also there. So in microgrid concept, we are integrating or we are making our own grid, where all these generators, you can say the solar is one kind of generator, wind is one kind of generator. All these renewable resources are combined at one place. They are forming as a microgrid, and then that energy is utilized wherever and whenever is required. So this concept can be utilized. Another is grid stabilization. So grid stabilization is important if your demand is not fixed, because again you are generating your power, your own power. You're utilizing grid also. You don't know how many vehicles are going to come at charging station at a time. So all these dynamics you have to consider and stabilize the grid, because if you unstable the grid again, that charges, demand charges will be huge. Penalties are there on the from the electricity board. Just to avoid that, we should stabilize the grid as well. So you cannot just think of utilizing whatever power available. So you have to think how I can utilize available power in an efficient way. So these are renewable energy credits, whatever is electricity generated. We can get credits as well, or we can tell the other whoever is producing this renewable energy, we can get from them and utilize that carbon footprint for our electricity utilization. Then policies are keep on changing, so we have to think of what government is giving the subsidies. We should utilize that tax credits. So there are a lot of other things also when you are deciding any power station to be built, or power or charging station to be built. So all these variables, all these whatever policies are there, the site requirements already we discussed. So these things need to be, I mean, planned properly. Then only we can have the better power station or charging station in our area. Otherwise, whatever situation was there, power crisis, maybe 4 or 5 years back. So same situation, we should not get trapped again, because if our EVs are increasing, power demand will increase. So we will have the power shortages. So just to avoid that, we should utilize this renewable energy, renewable resources to power up this additional requirement with that renewable energy, and reduce our dependency on the existing whatever infrastructure we are having. If we can able to do that, then I think will nobody can stop India from having the EV. I mean, in next 5 to 10 years. Again, these are some challenges. As I said already, uh, the intermittency of renewable, high initial cost, so space requirement will be there, grid upgradation is there. So all these, when we are means planning, so right now we are not thinking in a broader way because the requirement is not there. So we are happy to install one power station at every station. But if you cumulatively, if you see this power requirement, let's say in a city of Jamshedpur, or maybe where I'm staying here in Pune, um, uh, almost thousands of these petrol pumps are available in one city. So even every station, suppose they are installing one charging station and taking power of, let's say, 10 kilowatt. So the requirement suddenly increases by 1 megawatt, 10 megawatt. So the power requirement is going to be increased. So these are the challenges now going forward. So we will come out with some solutions as well. So these are some points what we are discussing here will be the requirement of our future, and our infrastructure should be ready as we progress. So the infrastructure, when we are talking, it is only about the road and water and electricity requirement of our day-to-day life. But this is again additional requirement of electricity, where if EVs are going to increase, this infrastructure has to be taken care, not only by the means installing more power or charging station, but the requirement behind that, how to get that power from available grid, available resources. So that has to be, I mean, thought has to be given on that subject as well, right? So I think with this, I'm done with the presentation, today's presentation. Thanks for staying with me.
Thank you, sir.
So
So, my dear participants, you can ask questions. Sir, you please see your chat box. I think some
yes,
participants have written.
yeah, Vivek Kumar Singh has written, what is the future of dynamic wireless charging in India? Uh, See, future is there, no doubt about it. Again, it depends whether it is wireless or you can say in Europe they built some roads with inbuilt what you call the electricity. So as and when you are running your vehicle on the road, they are getting charged. So we have not reached up to that level, but certainly this going to be the future in EV. If we are increasing our EV uses by multifold, maybe by next 5 to 10 years, if you see this. Already Europe, they have now stopped using this IC engines. They are totally now depending on these EVs. So there the infrastructure is totally different. They have the power, they have all these requirements. So wireless, yes, no doubt about it. But is the huge demand will be there because I don't know, but again, the challenges are there to develop that much power in wireless. So the infrastructure is developing. We are into the development phase of having these facilities in India as well. But the requirement is not reach up to that level. So as I said, we have to first focus on the existing infrastructure, how we can utilize it in better way. But yes, this will be the future of our charging industry. So requirement is there, huge requirement is there. So another is what strategies should automakers adopt to ensure affordability of EVs for mass adoption. So here again, initially since our cost of batteries were high, government has given some incentives to the automakers to have the subsidies on whatever batteries they are using. Now government is promoting Make in India batteries as well. So there are companies coming forward to manufacture these batteries in India. So once the raw material is available, or you can say the whatever material is required for producing any EV, unless that material is cheaper, you will not get the cheaper vehicle. But of course, if you see the trend, the prices are going down. So if I take example of, you must be aware, Tata vehicle, Tiago. Uh, Initially, when it was launched, it was priced around 15 to 18 lakh. Now it is coming at the rate of your IC vehicle, petrol vehicle. So just additional 1 or 2 lakh rupees you have to give, and that price is as good as your petrol vehicle. There are other schemes are also means coming into this field where means batteries are given on rent basis, or they are charged at per kilometer. I think I don't remember that. I think MG has come up with that scheme. So they are charging the customer for the kilometer uses of batteries. So their vehicle the battery cost is not included into the vehicle price. So it is cheaper than what we are getting the petrol vehicle. So I think that Comet is there, and another 1 or 2 brands of MG. They have this scheme where the price of vehicle is less than 5 or 6 lakh without battery, and battery they are giving on a rental basis. So these are the scheme. Manufacturers are also coming out, and it is affordable to the user also, because the fuel cost is very low compared to this petrol. Our foreign currency, we can reduce it by utilizing our resources in renewable resources, energy. So these are the means areas where we have to focus to reduce the prices. Yeah. In India, what is this? Ready for a large number of EV cars. What is the timeline? Yes, we are ready. If you see this, this is the emerging field in India right now, and uh, we are getting more and more this what you call people are coming. Earlier, if you see this, Maruti was hesitant to produce the EV in India because they thought infrastructure will be the challenge for EV. But now they are also coming with some variant now. Earlier they were focusing only on the hybrid. but now they are coming out with EV. So two-wheeler already, I think 50% people are thinking of going for EV. Similarly, one day will come. That day is not too far. Maybe I can see by 2030, this 50% of our vehicle will be EV. That is how I can see the market here now because of their uh, efficient way of utilizing the cost. And government is also promoting to scrap the old vehicles. So they are also giving some incentives, more benefits to the user as well.
Thank you, sir.
Thanks, thanks.
Thank you be with us from last two session you have delivered, right? So, sir, we will meet again. Either I think your lecture is scheduled again in next FDP also, right?
I think it was only 2 lectures.
In next FDP also 2 lectures are there.
Okay.
Okay, so we'll meet again, and in future also we will try for physical mode. Thank you, sir.
Sure, sure. Thanks a lot for providing me this opportunity to interact with the budding engineers here. So they are our future, and I hope from here, whatever insight they got of this industry or upcoming industry, they will come out in your guidance. They'll come out with some brighter ideas, which will help in this industry to grow at a faster rate. What we are means assuming or predicting, because these are the people who are going to drive this industry now. So we need, you can say, the young blood here in this industry who can drive this, because this is the future of India now, at least for EV. And similarly, I could see the future in a battery energy storage system as well, where our dependency on power will get reduced because we have to utilize maximum and maximum this renewable resources, whatever is available.
Thank
So
you, sir.
thanks a lot. Thank you
Okay.
again.
Okay,
Thank
sir.
you, everybody. So we'll close our session here. Thank you all. I'll take your permit to sign off. Thanks.
I think you unmute Dr. Minal.